Now we're going to look at some definitions of how derivatives can be used to explain increasing and decreasing components of a graph. We're going to use the fact that when a derivative is positive, then a function is increasing, and when one is negative, it is decreasing. So first, let's look at what it means for a function to be increasing and decreasing. So let f be a function defined on an interval I, and let x sub 1 and x sub 2 be any 2 points on the interval. Then f is increasing on I if x1 is less than x sub 2. This means that, for example, this can be the point 1, then this has to be a number larger than 1, like 2. Then the output when of f evaluated at 1 is less than the output of f evaluated at the second point. So for example, if here's my graph, then my graph is going, if my x value is here, and this is its output, then the x value over here, the output must be larger, so it's increasing. Similarly, decreasing is the exact opposite. If the first x value is smaller than the second x value, then the first y value is larger than the second y value, something like that. This can be extrapolated to derivatives, because if the derivative is positive, then that means the function's increasing, and if the derivative is negative, then the function is decreasing. This is because the derivative is the slope of the tangent line. So that means that if the slope of the tangent line is negative, the function must be decreasing. If the slope of the tangent line is positive, then the function must be increasing. So let's look at how we can use this to determine increasing and decreasing sections on a graph. This will be used in later sections when we actually graph functions based off derivatives and second derivatives in the coming lessons. So we want to determine the interval on y equals x squared where the graph is increasing and where the graph is decreasing. So what we do then is we're going to take the derivative of this function right here. So we get d dx of x squared is equal to 2x. Now I want to go look at the graph really quick, and I know we all know what x squared looks like. X squared looks something like this, the green graph right here. So you can tell just right away that if I put a point on this graph like this, and then put the tangent line like this, and then move this point around, you can see how right here the derivative is negative, and here the derivative becomes positive. So here it's decreasing, here it's increasing. Now what actually graphing the derivative does is we can just look at the derivative and we don't even need the function. If I told you that this was the derivative, then from 0 to infinity, my original function increases, and from negative infinity to 0, it decreases, which is absolutely true. So our function then is decreasing on the interval negative infinity to 0 because f prime of x is equal to 2x is less than 0 on the interval negative infinity to 0. Our function is increasing on the interval 0 to infinity because f of x is equal to 2x is greater than 0 on the interval 0 to infinity. That's basically all there is to it. You just have to determine where the derivative is positive and where the derivative is negative. So what I want you to do now is try this problem. Try to determine the intervals on y equals x squared minus 4x, where f of x is increasing and where f of x is decreasing. Okay, good. So let's just do it together and make sure we're all on the same page here. So the very first step is to determine the derivative. So we do d dx of x squared minus 4x. This is going to be equal to 2x minus 4. Now we need to find the value at which the increasing and decreasing changes. So what we do is we set this equal to 0. It's what we did in the last problem, but because it was just 2x, we recognized right away that it's 0. So you get 2x equals 4. So x equals 2. So this is going to be our critical point, and this is going to be where the derivative changes from negative to positive or positive to negative. So then we determine that our function is decreasing on the interval negative infinity to 2 because 2x minus 4 is less than 0 on the interval negative infinity to 2. And our function is increasing on the interval 2 to infinity because 2x minus 4 is greater than 0 on the interval 2 to infinity. And that's it. That's all there is to it.